Spontaneous reactions occur naturally, without any outside input of energy. In fact, they release energy that's available to do work. Now, a reaction that releases energy sounds like an exothermic reaction, but not all exothermic reactions are spontaneous, and not all endothermic reactions are non-spontaneous. So we can't only look at enthalpy to determine whether or not a reaction is spontaneous. We also need to consider entropy and temperature. We're going to calculate Gibb's free energy, which is the change in free energy, or energy that's available to do work, by subtracting delta H minus T delta S. When delta G is negative, the reaction is spontaneous, so it occurs naturally on its own. When delta G is positive, the reaction is non-spontaneous, which means it won't happen unless we give it enough energy to make the reaction occur. So in order for a reaction to be spontaneous, delta G needs to be negative. So when delta H is negative and delta S is positive, delta G has to be negative, which means an exothermic reaction that is increasing in entropy will always be spontaneous. Again, reactions are spontaneous when delta H is negative and delta S is positive, because it means delta G will always be negative. And a negative delta G indicates a spontaneous reaction. So let's look at some other possibilities for enthalpy and entropy and how they affect spontaneity. We already said that when delta H is negative and delta S is positive, that will always give us a negative delta G, which is a spontaneous reaction. When delta H is positive and delta S is negative, that will always give us a positive delta G, which is a non-spontaneous reaction. When both delta H and delta S are negative, the temperature has to be low in order for delta G to be negative. So the reaction is only spontaneous at lower temperatures. When both delta H and delta S are positive, the temperature has to be high in order for delta G to be negative. So the reaction is only spontaneous at higher temperatures. Since a negative delta H causes a reaction to be spontaneous, we would call an exothermic reaction enthalpy-driven. And since a positive delta S causes a reaction to be spontaneous, we would call a reaction that's increasing in disorder entropy-driven. The example says an endothermic reaction is spontaneous. Since the reaction is endothermic, it's not enthalpy-driven, so it must be entropy-driven.